In this video, we will be reviewing sections 7.1 through 7.4. Starting in 7.1, we begin with the Pythagorean theorem. So the Pythagorean theorem is used for right triangles if we have two of the legs or two of the sides and want to find the third side. So typically we label the sides A and B and we call the hypotenuse C. So a squared plus b squared equals c squared. This is my hypotenuse. That's one of the most important pieces of information. And both of these are the legs. So we can either solve for a missing leg or the hypotenuse. So here is an example of doing it both ways. So let's go ahead and say that this is 3. I don't know what this side is, but this is 5. So I'd set it up. A squared plus b squared equals c squared. I'm going to go ahead and say a is 3, so that's 3 squared, plus b is x, so I'll make that x squared equals 5 squared. So that is 9 plus x squared equals 25. Subtract 9 from both sides. X squared equals 16. Then I need to take the square root, and x is equal to 4. In a similar fashion, if instead I'm missing my hypotenuse, I could go ahead and say this leg is 5 and this leg is 12, and I want to find y. So 5 squared plus 12 squared equals y squared. 25 plus 144 equals y squared. 169 equals y squared. Then I need to take the square root, and y is equal to the square root of 169, or 13. And we did cover some problems where the square roots don't come out evenly. So for example, the square root of 169 does come out evenly to 13, but what if instead it was the square root of 170? So I taught you guys to go ahead and break it down. So instead of the square root of 170, break it down into factors. So that's 2 times 85. So you can break apart 170. And so then I can break apart 85 even more into 5 and 17. And I can't actually break 2, 5, and 17 down any further, so because I can't take the square root of any of those pieces, I'm just going to go ahead and put them back together. So your final answer, if you wanted to take the square root of 170, in simplest radical form would actually just be the square root of 170. If I change my number a little bit, if I make it the square root of 72, when I break that down, that's the square root of 2 and the square root of 36. I can take the square root of 36, and that part is equal to 6, and I keep that as a square root of 2, and then I go ahead and move that 6 out in front, 6 radical 2, because I don't want to accidentally think that this is 26. Alright, so the square root of 72 in the simplest radical form is 6 radical 2. In 7.2, we use the converse of the Pythagorean theorem. So instead of saying we do have a right triangle, here we use the relationship c squared is equal to a squared plus b squared, and we prove it. So if this is true right here, if it's equal to, then that gives you a right triangle. Alright, so you got to make sure you know where your C is, where your A's and B's are, and exactly how your sign is facing. So c squared is less than a squared plus b squared. That means c squared is less than, c got smaller, so your hypotenuse got smaller, making it an acute triangle. And therefore, when c squared is greater than a squared plus b squared, we have the opposite problem. It is an obtuse triangle, so we can classify them. So, for example, I have 6, 8, and 9. I need to choose 9 as my C because it is my largest side. So I set it up, 9 squared, question mark, 6 squared plus 8 squared. So that's 36 plus 64, and this is 81. I know that this is 100, and 81 is less than 100, so that makes it acute. In 7.3, we use one specific theorem to use similar right triangles. So let me go ahead and draw out an example. So first we do start out with one large right triangle. And what it says is if we have an altitude in that right triangle, that creates 3 similar triangles. So I've got this medium-sized yellow one, and I've got this small-sized one, and I, of course, have my large original one. So what is really going to help you guys is making sure that you redraw it. Redraw, and relabel your sides in order to set up proportions and solve. So working an example, this would have 4 labeled here on the altitude, and 2 here and x here. So I'm going to go ahead and redraw whichever way. This is my large, this is my medium, and this is my small. And it's just helpful to always put in the right angle and kind of see which one's your smallest angle. So according to my large triangle, I don't have this side, this left side, and I don't have the hypotenuse quite. I don't have either legs, but I do have the hypotenuse in the form of 2 plus x using segment addition. In my medium triangle, I have 4 on the height and x on the base. And for my small triangle, I have 2 on the height and 4 on the base. So you should be able to use these 2 triangles because they have the corresponding sides. So I can do 4 over x equals 2 over 4. That should work out. And cross multiply, I get 2x equals 16, x equals 8. The biggest challenge with problems like this is redrawing them and labeling the sides correctly. And we spent plenty of time in class working on those problems. If you need additional help or some pointers, please feel free to see me before school. In our last section, 7.4, we discussed special right triangles. So we have 2 types. We have a 45-45-90. Alright, so as long as I give you one of those, and a 30-60-90. Alright. What that said is we have a couple of relationships. In a 45 right triangle, both of our legs are the exact same since both of the angles are the same. Alright, we've used that theorem in the past. And then it said whatever the leg length is, take that times radical 2, and that's the length of your hypotenuse. And in a 30-60-90 right triangle, it says you have the short leg, and if you multiply that by radical 3, get the longer leg, and if you multiply the short leg again by 2, you get the hypotenuse. So, for a 45-45-90, this is one equation you need to know. Leg times radical 2. And then for a 30-60-90, these are the 2 equations you need to know. The hypotenuse is equal to 2 times the short leg, because we have 2 different size legs here, and the long, I guess I'll rewrite it so you can read it, and the long leg is the short times radical 3. Alright, and we can solve for any which one of the sides given certain information. So I'll look at a couple of examples there. Alright, so let's go ahead and say this is 45 degrees, and this is radical 5. Alright, so I want to go ahead and find h for my hypotenuse. So what I need to do is take my radical 5 times radical 2, according to my formula, and get radical 10. And that is done. If I did get something like, for example, a triangle where it was radical 18, if I were to do that, and I multiply by radical 2 and get square root of 36, go ahead and take the square root if it comes out evenly. Alright, and if you were given something like 3 square root of 2, what happens with that when you multiply it by square root of 2, those become a square root of 4, which is equal to 3 times, take the square root, 3 times 2, or 6. Alright, if instead for a 45, 45, 90 right triangle, you are given the hypotenuse, let's go ahead and say that it is 3 radical 2. What you do is you have your hypotenuse equals leg times radical 2. Fill in what you have. 3 radical 2 equals leg times radical 2. Divide each side by radical 2. And your leg is equal to 3. Alright. In a 30, 60, 90, I can give you one of the 3 sides, and we can deal with it. So, if your short side is 3, it's got to be across from 30 degrees in order for me to know that. Then, I need to multiply that by radical 3, and that's your long side. And if I double it, that's going to give me your hypotenuse. If you were to actually calculate this out, you would see that it's less than 6, so it makes sense. Another example, if I start out with the long leg, alright, and I give you, let's go ahead and say radical 27. Radical 27. So my long leg is equal to my short times radical 3. So radical 27 equals s times radical 3. Divide each side. And 27 divided by radical 3 is equal to the square root of 9, which is 3. So my short side is 3. And then I go ahead and double that for my hypotenuse. Alright, and if I were to give you your hypotenuse, finally, this is 30, hypotenuse equals 14. Well, go ahead and chop that in half. So hypotenuse equals short times 2. So 14 equals 2s. S is equal to 7. And then multiply that by radical 3, and you have all 3 sides. Alright, good luck studying.